Welcome to CognitionChunks. This information is for entertainment only. I am not trained in philosophy. Is this useful? Is this nonsense? Join me as I attempt to learn from GPT. Here is Pythagoras according to GPT. Episode 6, The Music of Spheres. Music of the spheres refers to an ancient philosophical concept that regards proportions in the movements of celestial bodies, the sun, moon, and planets, as a form of musica, the medieval Latin name for music. In modern times, this concept symbolizes the intricate and harmonious nature of the universe. It is rooted in the philosophies of Pythagoras, Plato, and later on, the developments in celestial mechanics by Johannes Kepler. Pythagoras, with his profound belief in numbers as the ultimate reality of the universe, extended this notion to encompass the movement of celestial bodies, suggesting that the planets and stars produce a kind of music by their movements, which, while inaudible to the human ear, reflects the harmonic nature of the cosmos. Foundation of the theory. Pythagoras discovered the numerical ratios that govern the harmonies of musical scales can be applied to the distances and movements of the celestial bodies. He observed that vibrating strings produce pleasant sounds when the ratios of the lengths of the strings are whole numbers, and similarly, proposed that the movements of celestial bodies, like the planets or the sun and moon, create a form of music in their ceaseless, perfect motions. How it works. This celestial music isn't heard in a conventional sense, but is rather understood as an expression of harmony and mathematical order. Pythagoras and his followers believed that the distances between the planets could be expressed in ratios that correspond to musical intervals. For example, the relationship between Earth and the Moon, or Earth and the Sun, could be conceptualized as forming a musical fifth or a fourth, based on the ratios of their orbits and relative speeds. The idea that the ratios of the maximum and minimum angular speeds of planets in their orbits could correspond to musical intervals is a fascinating blend of astronomy and music theory, echoing the ancient concept of the music of the spheres. This concept, although not based on modern astronomical principles, ties into historical observations and philosophical interpretations of how the universe is ordered. Understanding angular speed in orbits. The angular speed of a planet in its orbit varies because most planetary orbits are elliptical, as described by Kepler's first law of planetary motion. The angular speed is fastest at the perihelion, the point in the orbit closest to the Sun, and slowest at the aphelion, the point farthest from the Sun. This change in speed is due to Kepler's second law, which states that a line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. Therefore, the planet must move faster when it is closer to the Sun to sweep out the same area as when it is farther away. Mathematical expression of angular speeds. The mathematical relationship for the velocities at these points can be derived from the conservation of angular momentum and Kepler's laws. The orbital velocity of a planet at a distance from the Sun is given by where g is the gravitational constant, m is the mass of the Sun, r is the radial distance of the planet from the Sun, a is the semi-major axis of the orbit. At the perihelion and aphelion, the velocities can be simplified. This gives ratio of velocities and musical intervals. The ratio of the maximum and minimum angular speeds, or velocities, can then be expressed as for planets in our solar system, which have orbits close to circular, do not deviate extremely from a, meaning the ratio tends to approach values that are simple ratios, similar to those found in musical intervals. For example, a ratio close to 2 to 1 corresponds to an octave, 3 to 2 to a perfect fifth, etc. Harmonic ratios between planets. When comparing these ratios between different planets, additional harmonies can be noted. For instance, the ratios of their perihelion to aphelion velocities might form relationships that mirror consonant musical intervals between various pairs of planets, suggesting a kind of harmonic relationship in their motions. Modern interpretation. Gravitational waves. In a modern scientific twist akin to the music of the spheres, the detection of gravitational waves could be seen as a real manifestation of cosmic music. These waves, caused by massive astronomical events like black holes colliding or stars exploding, ripple through the fabric of space-time much like sound waves through air, and they can be heard with the right instruments, such as LIGO, Laser Interferometer Gravitational Wave Observatory. Planetary resonance. Planetary systems, including our own, can exhibit resonances that are the gravitational equivalent of musical intervals, where the gravitational pulls between planets result in periodic effects that stabilize the system, much like how certain pitches can resonate harmoniously. The music of the spheres, then, remains a powerful metaphor for the underlying order and beauty in the universe, reflecting how ancient philosophical inquiries continue to inspire and intersect with modern scientific understanding. In conclusion, while the music of the spheres as originally conceived isn't about literal sound, it emphasizes a profound insight into the mathematical framework underlying the cosmos, reflecting the intrinsic order and harmony in the natural world. This perspective has inspired both scientific inquiry and artistic expression through the ages, linking the motion of celestial bodies with the aesthetic principles of music. Thank you for joining us for another Cognition Chunks. Please like and subscribe.